In this video, we'll see how to solve systems by graphing. And what is a system? A system is a set of two or more equations. So we have a representation of two or more lines on the graph. If we're solving the system by graphing, we are going to have two or more equations which represent two or more lines on the graph. In the system, to find the solution means find the value of the variables. So the value of the variables, x, y, that make a true statement being replaced in both equations. A solution is a common point that belongs to both lines. In other words, if I replace the solution in both equations, I have to have a true statement, and I'll show you a little bit later how that works. On the graph, the solution is the point of intersection. If we have a graph, let's say two lines being somewhere on the graph, they will intersect in only one point. That point of intersection will be called solution. It can be anywhere on the graph, and the lines can have different orientations, different directions, but that point of intersection will be our solution because that would be the only point that belongs to both lines. Another way the lines can be on the graph is running like this parallel. That means that these lines will never intersect, so the point of intersection will not exist if I have parallel this way, parallel this way, parallel this way. Going on forever and ever, the lines will never cross. So that's when we're going to have no solution because there will be no point of intersection. If the lines cross, it will be always one solution because two straight lines can only cross in one point. If the lines run parallel, that means that there will be no solution because there is no intersection point. And there is one more situation where the lines actually overlap. So they are identical to each other. In other words, by graphing them, it will be one line and the other one will be right over it. Overlapping lines have all the points of one line in common to the point of the other line. So that's when we're going to say that the solution has infinitely many solutions. So the system has infinitely many solutions. So we have one solution for two intersecting lines, no solution for parallel lines, and then infinitely many is when in the system the lines are identical, they overlap. Let's see how that works with numbers in the actual system. So we have a system of two equations, and we need to solve the system. To solve means find the xy ordered pair that is in common for both equations. First equation is y equals negative x, where the slope is 1 over 1, negative minus 4, that is the y-intercept. So through negative 4, I'm using negative 1 by 1 slope. And using multiple counts for accuracy as many times as it fits. So first equation is a negative line going downward to the right, going through negative 4 on the y-axis with negative 1 by 1 slope. Second equation, y equals 2x plus 2, has to go through 2 on the y-axis, that's my y-intercept, and then 2 over 1 slope, that is upward 2 by 1 count, vertical 2, horizontal 1, or rise 2, run 1, but the line itself going upward because the slope is positive, so upward. Now my two lines crossed in a point. So this is when we say that the system has one solution, because that is just one point of intersection right here, and the coordinates x negative 2 and y negative 2. So the x value is negative 2 and the y value is negative 2. In our system, the solution is the cross point, and we can check the solution by substituting the x and y coordinates in both equations. So in order to check, in the first equation, Instead of y, we put negative 2. And then negative 1x means negative 1 times the x value, negative 2 minus 4. So I am substituting our y negative 2 and x negative 2 in the first equation right here. And we want to make a true statement or see if it makes a true statement. So negative 2, negative times negative is positive 2, bring down negative 4. 2 minus 4 is negative 2, and that makes a true statement. The solution is a true solution if it is making a true statement in both equations. So in the second equation, if I substitute instead of y negative 2, multiply times x, which is negative 2, we have negative 4 plus 2, and that one is negative 2 equal negative 2, true statement as well. So in order to prove that the solution is found correctly, you have to substitute the x and y coordinates in both equations, and that is based on our definition up here. A solution is the value of the variables x, y that make a true statement when being replaced in both equations. So we have to make sure that it makes a true statement in both equations. The second type of equation, or the solution, if we have a line going with the slope half x through 1, so slope half upward positive through 1, and then in the second line we have the slope again half. It's written as x over 2, but if we have that hidden coefficient 1x over 2, which makes the slope half, and this line goes through negative 2. So the line is going the same direction as the first one. So first line has slope half and second line has slope half. That means that both lines go same direction and they will go parallel to each other. So when we read this solution, we don't have an intersection point. There is no intersection point for us to check. That's when we're going to say that the system has no solutions. There are no common points for these two lines, so there's no intersection point. So the system has no solutions. And in the third situation, we're going to see infinitely many. Let's see how that shows up. Y equals 4x plus 4. So we have a line going through 4 with the slope 4 by 1. So 4 by 1 upward. And in the second equation, the equation has the slope 8 by 2, but 8 by 2 simplifies to 4 by 1 as well. So if I rewrite this equation, if I use the simplified slope, 8 divided by 2 is 4 by 1 x, and it goes through 4 y-intercept. So this first equation and second are completely identical after we simplify the second equation. So that has 4, again, y-intercept. And the slope is exactly the same, 4 by 1. So what's going to happen is if I want to draw the second line, that it is completely overlapping with the first one. So that's when we had two lines, one over the other. All the points are in common. So every single point is in common. So this is when we say infinitely many. Solutions. Every single point from one line overlaps with another point on the other line. Let's see here to check. What point should I pick to check? I can pick any point on the line. Let's say I pick any random point such as -2, -1, 2, 3, 4. So let's say I check -2, -4. And I put in the first equation, which is exactly the same as the second equation, y equals 4x plus 4. the point, -2 will be our x value, so 4 times -2, and -4 is the y value. -8 plus 4 is -4, and that works. If I check another point, let's say I check this one, it's 1, 2, 3, 4, 5, 6, 7, 8. And I plug in the same equation, so I'm going to check point 1, 8, and that would be, instead of the y value, we put 8. Instead of the x value, we put 1. So we substitute the x and y values, 4 plus 4. Again, a true statement. So every single point that I pick off these lines, because there are 2 lines here overlapping, will always make true statement. So that's why we say that every single point, it's infinitely many solutions when the lines overlap.